Question 12. Negative 3 is less than n, which is less than or equal to 1, where n is an integer. Part A, write down all the possible values of n. Well, initially we can see that because n is an integer, we're dealing with whole numbers, and the numbers are going to be between negative 3 and 1. So we have negative 3, negative 2, negative 1, 0, and 1. But now we need to look carefully at what the symbols are. Now the second symbol says that n can be equal to 1. So 1 is okay, it's an acceptable value. However, the first symbol says that negative 3 is less than n. So n cannot be equal to negative 3, so we don't include it. The only possible values are negative 2, negative 1, 0, and 1. For part B, solve the inequality 3p minus 7 is greater than 11. This can be solved exactly the same way that a linear equation can if this was an equal sign. We keep everything balanced. To solve the inequality, we need to find out what p is. To leave p on its own, we're going to work backwards through this left-hand side of the inequality. So we've got 3 times p, subtract 7. To undo that, instead of subtracting 7, we're going to add 7. Now that will get rid of the negative 7 and leave us with 3p. The greater than symbol stays facing the same direction, but we have to remember to keep this balanced, we add the 7 onto the right hand side as well. So 11 add 7 is 18. If 3p is greater than 18, we can divide both numbers by 3 to find out what p is greater than. If we do the same to both sides, it keeps the inequality balanced. 3p divided by 3 is p. The greater than sign stays the same. 18 divided by 3 is 6. So the solution to our inequality is that p must be bigger than 6.